Hello, welcome back from Easter. I hope everybody had a really nice Easter at home with your family. I know we had a pretty quiet day around here, but it was fun nonetheless, and I hope you all had a good time too. We are continuing the gas laws, and our last assignment was to finish up doing 5A through F. And today I want to do 6, and I want to move on to a new set of laws in 8. Now, there's something, because 5A was in Kelvin, I neglected to share with you. And that is that when we have degrees Celsius, we want to convert. Anytime we have a temperature calculation, we want to convert from, oops, that's FROM, from degrees Celsius into Kelvin. And we're going to continue to do this just from here forward. So if we take any amount in Celsius, let's say we have 33 degrees Celsius, and we need to convert that into Kelvin, all we have to do is add 273 to whatever it is, and that will equal the amount in Kelvin. So pretty dang easy. You can write that 273 on your periodic table, so it's always sort of handy for you. So let me show you. I'm going to take 33 and add 273 to it, and I get 306. And that's all there is to that. So it's just an additional step, and I'll show you how it's going to look in our problem. We are going to do 6. I think I already mentioned that. And so this is a word problem. And in our word problem, this is cool because it's how bread gets all spongy, is a story of a bubble in bread. And the bubble comes from cellular respiration, because when you have your piece of bread, it has bubbles in it, and the little yeast that's in there is taking and it's eating the sugar and the carbohydrates that's in the bread and converting it into ATP for its body so it can grow and reproduce. But as it does that, it increases kind of the volume of its area where it's located inside the bread. And that's how bread gets big and spongy as it rises, which is kind of a neat deal. So here we go. We have a small amount of volume in the beginning, but as the bread rises, it increases, and that's what we're looking for, is how much did it increase. And here are temperatures, but they're in Celsius, and so darn it, we're going to have to convert those to Kelvin. So just like all the other problems, I want you to start with the base equation and rearrange it to solve for your unknown. In this case, our base equation is Charles's law, so it's V1 over T1 is equal to V2 over T2. And we are solving for T2. No, we're not. We're solving for volume 2. So that's pretty easy. Solving for volume 2, that's the volume of the bread after it's risen. And so this T2 just needs to move over. So I'm going to rewrite this over here as V1 times T2 divided by T1 is equal to V2. So all I did was rearrange the equation by isolating the V2 on the right side of the equal sign, and I moved this T1 over. And if I move it over, I need to move it up or into the numerator. So now what we'll do is I'll plug in our numbers. We have, we could do a data table if for those of you who need that. If you don't, that's fine too. In this case, we have volume 1 is 1.15 centimeters cubed, and temperature 1 is 22, and volume 2 is our unknown, and temperature 2 is 99 degrees Celsius. Okay, so now we can plug in our numbers and solve this problem. So V1 is 1.15 centimeters cubed. And we're multiplying that by temperature 2, which is, I'm going to put parentheses up, it's 99 degrees Celsius, but we want to turn that into Kelvin. And so we'll add the 273 to get that done. And down below we have temperature 1, which is 22 degrees Celsius plus 273. It is true, you can go ahead and add your 273 here and here and get your numbers in Kelvin before you start to solve the problem. You might want to do that, especially if you're not super good at your calculator. So you, in order to solve this problem, need to add these together first and then multiply them here, save that result, add these together, and then divide them. So I'm going to go ahead and do that really quick. I've got 1.15. I'm going to add these, and I'm going to save that 1.15 off to the side, and I'm going to add these two together, which is 99 and 273. And so now I can multiply this 115 by the 27, well, by that number there. And then I'm going to take my 22 and add it to the 273 and then divide the top by the bottom. And so I get 1.45. And that is centimeters. That should be 145 centimeters and cubed. And let's see, I've got two significant digits. 1.5 centimeter cubed should be my answer. And that's all there is to it. So I know it seems weird to start doing this Kelvin conversion, but we are going to start doing it now. And from here on forward, as we deal with temperatures, I believe every single time we will be converting it into Kelvin. So just get used to it. It's not that big of a deal. Just add it up. And then we wanted to not only do 6, but I wanted to do 8. Is that right? 8A today, which is a new law. It's the Gay-Lussac's law. And it works by P1 over T1 is equal to P2 over T2. And we are going to continue to do the Kelvin conversion. So in 8A, well, let's first rearrange the equation. We're solving for T1, which is here. So that means it needs to come up, and all this needs to flip over and move over to the other side of the equation. So let's get that done. We're going to take P1, which stayed right where it was at, and we're going to multiply it by T2, and then divide the whole thing by P2 is equal to T1. If you're having trouble rearranging equations, contact me and I'll try to talk you through it. There's some stuff we can do to make it easier. So now that we've done that, we want to plug in our numbers and solve. So for P1, I have from the worksheet 8A, I see 0.777 atmospheres times T2, and that's going to be 192 degrees Celsius. And remember, we want to add the 273 so that we can make that Kelvin. And then I'm going to divide that all by P2, which is 5.6 atmospheres. So this times this divided by this is going to be equal to our temperature 2, but that'll be in Kelvin, so we need to convert it back to Celsius because that's what it wants the answer in. So let me get my calculator and show you how that's done. We're going to start here inside the parentheses, and we'll multiply it by the 0.777 and then divide it by the 5.6. So I end up with 64.5. I've got two significant digits, it looks like, so that's going to be 6.5 times, or 65, let's just say. So that's 65 Kelvin. So I want to take that 65K and subtract 273 from it to get my amount in Celsius. All right, so 65 enter, 273 minus is going to be negative 208 degrees Celsius. All right, so that's how you're gonna do that. And let's see, there's something. Nope, that's it. 2 significant digits. I was thinking that was off, but nope, we've got 2 significant digits. We should be fine with that. So that's how we're going to solve those problems. And you can do 8A through 8F and fill in the Google form. So that's 8A through F and 7. We still have to do 7. So you guys are going to work on that. Fill out the Google form and I'll check it and see how you're doing. I hope you all have a great evening and a great day tomorrow. So you have, a couple days to get this done. So go for it. All right. Have a good night.